Hello students, welcome to my YouTube channels. Today I am going to discuss the simple concept of the thermal stresses. Simple concept of the thermal stresses. How we'll develop the formula? How simply we can remember the formula and what is the concept behind that? So what I am doing, first we taken one bar and normal temperature, suppose it will be 30 degree. Now we will increasing the temperature to 60 degree. As we know, due to the temperature difference, thermal stresses will develop. So body will elongate due to the temperature difference. So what will happen if temperature will increase, body will get elongate. Body will get elongate. Suppose this is length L. This length will be delta L. Delta L is elongation. So what we are seeing here, if temperature increases here, body will get elongate. Then again, similar second case, temperature will reverse. Suppose 60 degree to 30 degrees Celsius. Now body temperature is reducing. Then body what will get? Body will come to the original position. That means contractions will take place. So what is second case? If temperature decreases, body will get contract. So body will get contract. It will come to the original positions again. But now another case. If yielding will be both end, that means we are making the rigidly fixed both end, that is called yielding. We are rigidly fixed both the end. Then what will come during the some temperature? Just I take an example, 30 to 60, that means temperature increases, because thermal stress is nothing but change the temperature. Is known as thermal stress. So what will be there here? Same temperature I am taking 30 degrees Celsius to 60 degrees Celsius, that means temperature increases. Then what is the concept here? And what will happen? Body will wants to elongate. Due to the difference of the temperature. But due to the yielding of the end, what they will do? Body wants to elongate up to there, but due to this yielding, due to the fixed end, they wants to bring back inside. They will not allow to cross this yielding point. So they will ask, come inside. This also body they will drag the inside, because they have restriction. They have restrictions here. So but body, due to the increase the temperature, suppose temperature here increases, body will get contract. Why? Because this due to the yielding, due to the fix, the elongations they will not allow to outside of this. So they wants to go inside, but they wants to pull back, come inside. They will ask, come inside, be the inside only. So that way it will be compressive. So contract. But now same here yielding will be there and temperature decreases. Suppose 60 degrees to 30 degrees. Now reverse. That means temperature here decreases. Then what will happen here? Body wants to, temperature decrease, body wants to contract. Suppose body will come contract here. But due to the yielding, due to the fixed end, what they will ask? Come back to this point. They will bring this to this point. That means this is the tensile. So what will happen? Tensile stress will develop. So tensile stress will develop here. Here contract na compressive stress will develop there. So that is known as thermal stresses, and thermal stresses will develop. So what we are seeing here, this is the free elongation. Free elongation means stress will not develop. Some example, suppose I given to our child 1,000 rupees and will ask him, should not give any account, go freely enjoy. So what they will do? They will freely enjoy. That means stress will not there, so he will enjoy nicely. But if they will ask that 1,000 rupees, you have to give the account. You have to give the account. So what they will feel? They will feel the inside stress. That means if body will freely elongate, stress will not develop. Body will freely elongate, stress will not develop. So suppose body freely elongate, stress will not develop. Stress will not develop. Body freely elongate, body will not develop, stress will not develop. But here we are not allowing to elongate the freely. We have restrictions. So you have to be here. You cannot go beyond this. So suppose they want to beyond this, they will ask, come this side, come inside. So they will bring the inside. So due to this compressive stress will develop. But due to the reduce the temperature, so it will compress. But again they will not allow to go inside. Come here. So be here. So that means they will pull back. That is called tensile. So this is the concept here. But now suppose we are stopping this block, elongation is stopping to some distance. That means yielding we taken that yielding, suppose that yielding taken is a delta. Then what is the elongation? What is the elongation? This is the special case. This is the special case. Okay. So here what formula will come now? We'll discuss. So once you know this concept, then how to derive the formula? See here. Elongation. Elongations depends upon the are proportional to temperature difference. You can write T2 minus T1 and length. See here. Elongation depends upon the change in temperature, 30 to 60, 60 to 30, no, change in temperature and length. Now, suppose this proportional will remove, then what will be the elongation here? Elongations will be, it will come alpha. Alpha na coefficient of linear expansion. This is alpha is nothing but coefficient of linear expansion. Change in temperature we can write like this, and T. So this is the elongation of the, this is the elongations of this body. Thermally elongate, body will elongate thermally. So this is the elongations of the body we know now. Once we know this, now suppose they will ask what is the strain. So strain is nothing but we know change in length to the original length. So what is change in length? See here, coefficient of linear expansions alpha, delta T, temperature difference into L by L. So what is the finally formula is coming? Alpha delta T. This is called strain of this body, strain. That is called thermal strain. You can see this is thermal strain. Thermal strain. Okay. So this you can say thermal strain. Now stress. How will develop the stress? How will write the formula for the stress? Stress is nothing but you know already Young modulus equal to stress by strain. Young modulus equal to stress by strain. So suppose this symbol will be strain. So what is stress equal to? Young modulus into strain. So we'll write here Young modulus into strain. What is strain? We have here E linear coefficient of linear expansions into delta T. This is the stress here. This is the formula for the stresses. So these two formula, if you remember, you can solve the thermal stresses, this problem. Whatever problems will come there, we can solve. Now, what is the special case here? If yielding will be after delta distance, yielding will, that means we are stopping this body due to the temperature changes, due to the temperature difference, but after some distance. So how much? Yielding is delta. Then what is the concept here? Change in length. What will be the change in length here? Change in length, that means alpha delta T L minus delta. This is the change in length that you have to, suppose this yielding will be after distance delta to minus. This is the elongations due to the temperature difference. This is the delta. Now, same formula we'll write here. What is strain and stress? Suppose we'll write the strain. that is called thermal strain. So everywhere this you will write here thermal strain, thermal stress, thermal stress, thermal strain. So here also same thermal strain. Change in length to the original length, change in length to the original length. What is change in length? Alpha delta T into L minus delta divided by L. If stress will be there, thermal stress. What will be thermal stress? Young modulus into strain. Then Young modulus equal to Young modulus into what is the strain here? Alpha delta T L minus delta total by L. This is the formula for the special case if yielding will be after some distance delta. So that is the case. So this way we know the formula for the strain, stress and special case. What is the elongations? Here this is the elongation. Once you know the elongation, substitute the formula, remember the answer like this. Now what we'll do here, we'll go the composite thermal stresses. So diagrams already we kept here. Then I'll explain this concept here. So what will be the constant behind that? This is composite thermal stresses. Composite thermal stresses. So composite means more than one bar. If you are combining together, that is called composite. So here what is there? Two bar is there, one copper bar, one brass bar. Due to the change in temperature, body will elongate. But one thing what you have to remember, alpha is nothing but, I will write here alpha is nothing but coefficient of linear expansion. Alpha is nothing but coefficient of linear expansion. This unit is per degree Celsius. That unit is per degree Celsius. So okay. So per degree Celsius. Now, how will composite bar? Suppose here I taken copper and brass. We taken here copper and brass bar. Okay, just wire. Copper and brass bar. Now we'll see the thermal expansions. Copper will be more. Thermal expansions of copper will be more than thermal expansions of the brass. That means copper bar will elongate more. Copper bar will elongate more. So what is there here? See, copper bar, two bar is there. Now copper bar elongate up to this delta L and this elongate up to this much. So that means what I am showing here, elongations will be more in the copper bar and elongations will be less in comparison copper bar. So this is the elongations. Now what we'll do here, we'll rigid body. One rigid body will fix at the end. Rigidly fixed the other end. What I did, rigidly fixed at the other end. This free elongation, now rigidly fixed. Then what will happen? Both will elongate equally. Elongations will be equal. So elongations will be equal. Now see this, copper and brass bar elongate after the increase the temperature, elongate up to this. Copper bar should elongate up to this because thermal expansion is more. Brass bar elongate up to here because thermal expansion is less. But due to the fixed, rigidly fixed bar, what they will tell. So this elongations they will avoid and they will ask to be inside only. That means up to there only. They will not allow to elongate. That means what will happen here? Compressive stress. Copper what will develop here? Compressive stress will develop. What will happen here? Compressive stress will develop. But due to the brass bar, elongations will be up to here. But due to the rigidly fixed body, because both bar will elongate equally, so they will pull back. That means what is this one? Tensile. stress will develop here. Here compressive stress will develop, here tensile stress will develop. This is the concept. Now how to write the formula? So two cases will be there. For equilibrium conditions, for the equilibrium condition, total compressive stress for the copper bar. So write like this here, compressive in the copper bar, compressive of the copper bar will be equal to the tensile of the brass bar. So this so here see, due to this compressive will be equal to load, compressive load will be equal to the tensile. So what is the here? PCU is equal to P brass. I am taking symbol brass B and copper. Now what is the stress? Because stress will tell stress nothing but, see here, stress equal to force per unit area. So force equal to stress into stress of the copper, area of the copper is equal to stress of the brass and area of the brass. This is the relation, one relation came. For the equilibrium conditions, total compressive stress will be equal to the total tensile stress because elongation will be same. So now another case, what is? Elongations of the copper bar will be equal to the elongations of the brass bar. So elongations of the copper bar will be equal to the elongations of the brass bar. We can write like this here. So elongations of the copper bar is equal to elongations of the, you can write also elongations of the copper bar is equal to, because due to the space I am not writing here, that is elongations of the copper bar always equal to the elongations of the brass bar. Okay. So what is happening here, you saw already, due to this copper bar elongations will be more, so it wants to come inside due to this compressive. See here, suppose this yielding is there, means body wants to there, but body, what they will do, they will ask to body go inside. So they will not allow to beyond this yielding point, fixed point. So due to the same reason here also, due to this they wants to pull back. So this is called compressive, but due to this here they wants to pull back in this rigid body. So this is a tensile. So this will be equal. Now here what is there? We know one thing. Suppose one body is there, apply the force P, body will elongate. That elongation is known as mechanical elongation. Mechanically elongate. So what is delta L here? PL by AE. That is elongations of the mechanically. What is thermal elongations? You see the thermal elongations, alpha delta TL. Thermal elongations will be alpha delta TL. Mechanical elongations PL by AE. So here, what is the concept here? The copper bar will elongate mechanically as well as thermally. So we can write here delta LCU, mechanical elongations, plus delta LCU, thermal elongation. You can write here suffix thermal elongation. Then equal to, similarly here, delta L brass, mechanically elongate, plus delta L brass, thermally elongate. Now what I told, mechanically elongate, this is due to the copper bar, compressive force will develop, Cu, PL by A, Cu and elastic constant, Cu, PL by AE. This is called mechanically elongate. Plus thermal elongations, what is? Alpha delta TL. That is linear coefficient of linear expansion, temperature difference into L. This came for elongations of the copper bar by mechanically and thermally, equal to, similar things here. Here tensile, so PS will be PS, PB brass, P brass, we are taking two bar, no, brass and copper. So P brass L by, because length will be equal, so always we kept length equal. Area of the brass and Young modulus of the brass plus alpha. So this alpha, no, alpha Cu also give here, see, alpha Cu, copper, because coefficient of linear expansions of the copper and coefficient of the linear expansions of the brass, delta T into L. Now you see here, how we'll solve or how we'll read the formula. This is the formula. Here also you can substitute, but something will reduce. L here, there, L here, there, both side L either, L get cancelled. Now what will reduce here? P by A is called stress. What is stress equal to? Stress equal to P by A. So that means P by A is there. So we can write here minus stress of copper by Young modulus of copper plus alpha Cu delta T, that is there, no, equal to. Here again Pb by Ab, stress of the brass, Eb of the brass, Ap by A, then plus alpha brass by delta T. This is all. This you can reduce the formula up to this also. Now one more steps you can reduce this formula. One more steps you can reduce the formula by taking common. So where we'll write? So this part I am rubbing it here. Already we did so. Okay. Now I will write here. So one steps you can write here. Take common. So alpha Cu this side. So bring this alpha copper minus alpha brass. Delta T take common. So delta T will be common. So this bring this side na minus. This minus na bring this side na plus. So what will write here? Stress by brass by E by brass plus stress by copper by E by copper. So this is the formula coming for the composite thermal stresses. Now whatever value they will give, substitute value, get the answer for this. Either they will ask stress develop, either they will ask Young modulus, whatever things they will ask. This is the formula for the composite thermal stresses. How this coming? Man, this part you have to remember. This part you have to remember what is, because elongations will be mechanically elongate and thermally elongate. Mechanical elongation PL by AE. Thermal elongations alpha delta TL. And you substitute, you solve this way. So copper and brass bar. Sometimes they will give copper and steel. So we'll see the thermal expansions, which bar will be more, that will elongate more. So this is the basic concept of the thermal stresses. If you understand this, very simple, big problems you can solve. Any competitive exam, GATE exam, university exam, whatever will be there, you can solve these questions. Okay, so watch this video, friends and students, and share this video to all your friends, and subscribe the channel. Then only we'll get the motivate, and we'll bring the like this some video for you. Okay, and so subscribe this channel. Those till now not subscribe the channel, you subscribe the channels. Okay, thank you, students.